Everyone, and welcome to the Safe Food Knowledge Network webinar on effective food safety for small food businesses. This is part one of our two-part series of webinars. So the webinar this morning will focus on the major foodborne pathogens, how to control these. We'll look at some case studies relating to foodborne pathogens in food facilities, and we'll also discuss cleaning and hygiene for small food businesses. So our first speaker today is Dr. Linda Gordon from Safe Food. Linda is Chief Specialist in Food Science and has extensive experience in food microbiology. Our second speaker is Dr. Kieran Jordon, who is Managing Director of Jordon Food Safety. Kieran previously worked in the Food Safety Department in Teagasc Park in County Cork. And like Linda, Kieran has extensive experience in foodborne pathogens, in particular research into pathogenic E. coli and Listeria. And our final speaker is Eddie O'Neill, who is Artisan Food Specialist in Teagasc and has a vast experience in this area. Eddie is the first point of contact for a range of inquiries from the public, including problem solving, product development, equipment, and packaging development. So I suppose just a bit of housekeeping before we begin. We have turned off all participants' microphones and cameras for this webinar, but feel free, please, to ask any questions throughout the sessions. You'll see a question and answer box at the bottom of your screen, so you can type in your questions, and we'll get to these at the end of all three presentations. So I suppose we'll kick off with Linda's presentation first, and I'll ask all other panelists if they please turn off their cameras and microphones until you're ready to speak. So I'll hand you over to Linda now, and we will begin. So thank you very much.
Thanks, Mairead, and good morning, everybody. As Mairead said, I'm going to talk about a little bit of background around food poisoning bacteria, the main types, some you'll be familiar with and others you may not be quite as familiar with. And then I'm going to talk a little bit about, how these bacteria can spread or get around a food premises and how to try and prevent that. So first of all, a bit of background, this is why you need to know about food safety, and this is why you need to be aware of food poisoning bacteria. These are the kind of worst case scenarios and the kind of headlines that nobody wants to see in relation to their food business. And there can be serious consequences, obviously, for food poisoning. In the worst case scenario, some forms of food poisoning can be fatal, and there'll always be people in our population who are more vulnerable than others, and we need to remember that. And a significant proportion, up to about 20 to 30% of the population would be officially in a vulnerable group when it comes to infectious diseases generally. So it's important to be aware of that when you're preparing or selling or serving food to the consumer. So this is a case of food poisoning that happened at a Christmas Day. So it's in the UK, I think, in a pub, where pubs can be open on Christmas Day, and they served a meal to a woman who became ill and then subsequently died. And then there was a prosecution, and the chef and manager were jailed. So obviously there were very serious breaches of legislation and breaches of their duty of care to their customers in that case. Other cases you'll probably remember, a few years ago, there was a major outbreak of salmonella associated in a restaurant pub in Dublin, and one woman became ill, so severely ill, and died afterwards. I think that was associated with a First Communion celebration. So again, you can have food poisoning outbreaks are going on all the time, and if anybody is signed up to get kind of alerts and things like that, you'll probably see these things crop up from time to time. Sometimes they're fairly localized. Sometimes we know what the cause was. In that case in the UK that is featured on that slide, there is an E. coli outbreak, and then extensive work is done to try and identify if a number of people become ill with the same strain of a food poisoning bacterium. Then extensive work is done to try and find what might be the common cause of that, or a particular food type or a particular premises or something. So again, not something that any food business wants to be associated with. How many people get sick from food? And that can be a very difficult question to answer. According to in the World Health Organization European region, they're saying every minute 44 people, more than 23 million a year, fall sick, with 4,700 losing their lives. But you know what? The food poisoning cases and the cases of foodborne disease that are reported are really only the tip of the iceberg. Because when you think about it, you know, most people, if they have vomiting or diarrhea, for the majority of people, that will be self-limiting. It will, you know, medical treatment won't be needed. And so they'll take a couple of days off and they'll stay at home and they won't go to the doctor. It's only in severe cases or for people who are more vulnerable or maybe very young children who might go to the doctor, or it's only if it persists beyond several days that people will go to the doctor. And even if you go to the doctor's not always going to be, you know, it's not always going to take a sample. So for a case to be reported, a person has to first go to the doctor and the doctor has to take a sample that has to be tested in the lab and then reported back. So the number of true cases of foodborne disease is many multiples of the numbers of reported cases that we see. So in 2018, EU member states reported a total of 5,146 foodborne outbreaks affecting over 48,000 people. And that's not the total number of food poisoning cases, because even that's just related to outbreaks. So where there's several people that have become ill or more than one person, like many cases will be sporadic illness where there's only one person becomes ill as a result of it. So most of those cases will go unreported. So in terms of bacteria, and they're one of the main causes of foodborne illness, although, you know, viruses like norovirus can also cause foodborne disease. But bacteria obviously are very, very small. They're microorganisms and they must be magnified at least 1,000 times in order to see them. So it's very easy, you know, you could look at something, you know, a surface in a food business and it might look clean, there's no food debris visible, but it may be contaminated with bacteria that you cannot see. And so that's why the cleaning and the sanitizing and all of that Eddie will talk about later is so, so important. There are some harmful bacteria, and the term that we use in food microbiology is pathogens, and others are not harmful. Some indeed are beneficial to us. So bacteria, one of the most common causes of food poisoning. Food spoilage bacteria are different to food poisoning bacteria. Food spoilage bacteria will obviously spoil the food by affecting the taste or the smell or the look of the food. But with food poisoning bacteria, they may be present in numbers that can cause illness, but they will have no effect on the taste, smell, or look of food. So you can't tell if something is safe to eat just by looking at it or tasting it or smelling it. I think a lot of people do that, and consumers do that with their kind of sniff tests. Oh no, it's fine, it's not gone off. You know, it may not be spoiled, but there may be harmful bacteria present in numbers that can cause illness. So food poisoning bacteria may cause problems in one of 4 main ways. So you can have transfer from raw to ready to eat foods due to poor handling and storage practices. So again, this is about avoiding cross-contamination from your raw ingredient to a ready to eat product or your cooked food. It can be caused by transfer onto foods from food handlers, from pests, dirty equipment and utensils. It can come from the food itself. It can be present, you know, naturally in the raw ingredients and then survive in food that is not cooked properly, not cooked to the right temperatures, or they can grow in food that is not stored at the correct temperature. So a lot of it comes down to temperature abuse. If you've stored your food at a temperature where bacteria can grow, or that you leave it sitting out after it's been cooked for, you know, a number of hours, you can have bacteria that will have survived the cooking process that are present in the environment that will survive. It's important to know that given the right conditions, and we'll talk about that in a minute, bacteria can grow to very high numbers in a short period of time. So every 30 minutes, roughly, the number of bacteria can double, and that's how they reproduce. They simply divide and double in that way. You can go from one bacterium to millions of bacterium in 12 hours. So it's the ability of bacteria to multiply rapidly that causes milk to spoil. So again, spoilage is caused by bacterial growth. And similarly, food poisoning bacteria can grow very rapidly given the right conditions. So looking at those conditions, temperature is probably the most important factor, although all of these are requirements for bacteria to grow in food. The temperature danger zone is above 5 degrees and below 63 degrees. So in that zone, bacteria can grow. Most food poisoning bacteria would grow best at 37 degrees, in and around that, because that's close to human body temperature. So that's the kind of temperature that they may be adapted to if they are the kind of bacteria that can be normally found in the gut of animals. A lower temperature means slower growth. So that's why we use temperature. We use heat and cooking to kill bacteria. We use refrigeration and freezing to prevent bacteria from growing in food. So this all relates to the storage temperature and the cooking temperatures. We're all trying to avoid our food being kept, for any time within this temperature danger zone. They need nutrients. Obviously, they're getting that from the food. And so we know the kind of food, the kind of high protein food and perishable foods, cooked, meat and those kind of things, dairy products are ideal for bacteria to grow, and they will have plenty of nutrients there to survive. They also need moisture, so they won't grow well in a very dry food, in a very dry product. If you think of dried pasta or something like that, bacteria won't grow because there won't be any water available to them. And also products like with high sugar, like something like jam, they won't have enough available water to allow the bacteria to grow. So that's why we use things like sugar and salt as preservatives. And then obviously they need around the right pH. If they're too acid or too alkaline, then the bacteria won't grow in the food. So just examples then of the ones that we're most familiar with. So salmonella, I think everybody is aware of. It can cause quite a severe illness in elderly people and in infants. And again, we're talking about the vulnerable groups, and you need to be aware of that. The symptoms: diarrhea, fever, stomach cramps. It can be life-threatening for those people, as we've said. The symptoms usually appear within 12 to 36 hours, but it can be 6 to 72 hours, anything within that, but most likely 12 to 36 hours. And you'll see as we go through the different bacteria, there'll be different incubation times or different times between eating the food and the symptoms appearing. And I think that's something that confuses people sometimes, because they think, oh, food poisoning will happen instantly or within 12 hours. But, it depends on the bacterium that is causing the food poisoning. Sources of salmonella, and it can be raw meat and poultry, raw eggs and egg products. So those would be from flocks that have not been vaccinated. But eggs aren't as much of a source of salmonella anymore, but you can find it in a whole host of things. Dairy products, you can find salmonella in spices and in dried things that can survive quite well in those, and given the right conditions, then they can grow if they're given the right conditions. Campylobacter is the most commonly reported food poisoning bacteria on the island of Ireland and across Europe. And in fact, the symptoms of Campylobacter: fever, headache, feeling of being unwell, severe stomach pain, and diarrhea, which can be bloody. So very unpleasant. 2 to 5 days is the incubation time, so the time between eating and becoming ill. But it can vary within that. It can be slightly less or it can be slightly more. Campylobacter is very commonly associated with raw poultry. A huge percentage of raw poultry contains Campylobacter. Campylobacter is perfectly adapted to living in the inside of the chicken, and then they're spread obviously very easily from one bird to another. But it can also be found in contaminated drinking water and in unpasteurized milk. So Listeria then is not as common. We see very few cases. It's unusual in that it can grow at refrigeration temperatures. So it can be found in foods that might have a long shelf life at refrigeration temperatures. And it's found in things like cooked meats, things like smoked salmon, soft cheeses, prepared salads, coleslaws, that kind of thing, can be commonly associated with Listeria. It has a longer incubation time. The symptoms may not appear for several weeks, 2 to 3 weeks, or it could be much longer than that. It's a significant one because although we may have very few cases, maybe there might be only 20 or 30 cases reported on the island of Ireland in a year, or even less than that sometimes. But the consequences are very severe. It causes fever, nausea, septicemia, meningitis. The people most vulnerable to this are older people, those who are immunocompromised, and pregnant women. Excuse me. So it can cause miscarriage. So the consequences of this are severe. So that is why. And it's also very commonly found in the environment. So that's why it's so important to get the control of this right. Now, there's a type of E. coli called VTEC E. coli that produces very severe illness, particularly in children. It has a very low infectious dose, so that means you only have to eat, a very small number of cells in order to become sick. The symptoms are fever, vomiting, stomach pain, and diarrhea, which can be bloody. It can cause kidney failure, and it can be fatal in some cases. We have quite a high rate of VTEC here in Ireland. The source is raw beef, particularly minced beef, for example, burgers. So that's why burgers should always be cooked the whole way through. And meat products, contaminated drinking water, unpasteurized milk, a whole range of foods can also be associated with salads and vegetables. Sorry, apologies for my dry throat. Staphylococcus aureus, we don't come across as often, and we think about it more as infections that people can pick up in hospital. It can produce a toxin in food. It's mostly caused by food handlers. Lots of people naturally carry Staph aureus on their skin and in their nasal passages. So it's very easy if you have poor food hygiene and poor, hand washing, to pass on Staph aureus to food. It produces a toxin which is resistant to cooking. So if it gets into the food and grows in the food before it's cooked, you could kill the bacteria, but the toxin may still be present. It can cause vomiting, diarrhea, nausea, stomach pain. Bacillus cereus is another one that produces a toxin in the food. Symptoms can appear within 5 hours. So again, the ones that produce a toxin, obviously they act much faster because you're not relying on the bacteria getting into your body and growing. The toxin will act immediately. It causes abdominal pain, watery diarrhea, nausea, quick acting, often associated with rice. And I know a lot of people are not aware of Bacillus cereus, but they know that reheating rice is something that must be done, with extreme caution, and, that you need to be really careful about. It's also associated with herbs and spices as well, and other cereals. Clostridium perfringens is another one that you might have heard of. It can grow rapidly at 43 to 46. It's another one that produces spores that can survive cooking. So you might find that in things like casseroles and things like that, or lasagnas or cooked meat dishes that have been left sitting around. Again, symptoms, because of the toxin involved that's produced in the food, the symptoms can appear much faster than they can for others. Clostridium botulinum, we are all aware of botulism. Thankfully, it's very rare. Found in canned, jarred, and vacuum-packed foods, the kind of foods that people would preserve, and the kind of cases that we hear across the world of botulism. These days, they're mostly associated with kind of home canning and home preserving. It only grows in the absence of oxygen, so that's why it's in something like a can or a jar that's sealed. And it produces a very potent and dangerous toxin that affects your nervous system and can cause, a whole range of symptoms, and eventually can cause muscle paralysis and damage, and can be fatal in severe cases. Again, symptoms appearing quite quickly within hours in a lot of cases. So again, those are the main kind of food poisoning bacteria. The ones we'll all be most familiar with would be Salmonella, Campylobacter, E. coli, Listeria. But the others, you need to be aware of as well. So how to avoid getting them into your food and spreading them around your food premises. We're trying to avoid cross-contamination, is where germs are transferred from one place to another. Examples, maybe you could have raw meat with dangerous food poisoning bacteria. If you cut it on a chopping board or in a meat slicer or something like that, any utensils or any equipment that comes into contact with the raw meat may contain the bacteria. If those aren't cleaned properly and you come along and use it for cooked meat or a prepared food product, then you can cause cross-contamination. So that's why the cleaning that Eddie's going to talk about is so important to prevent this. So preventing cross-contamination The main points are cleaning as you go, washing your hands. We're going to talk about this in a minute. Using cleaning agents and sanitizers. Just a rinse off, a quick rinse of your hands under the tap, a quick rinse of your knife or your utensils under the tap won't cut it. And Eddie is going to talk about the cleaning side of things, and separating the raw and ready to eat food. So bacteria can travel on your hands. Bacteria, jewelry can harbor bacteria. Tools and equipment, if they're not properly maintained and properly cleaned. Your hair, this is why people wear hair nets, water, food, a whole range of things can transport the bacteria from one place to another within your business premises. Bacteria on your hands, and that's somebody putting their hands down on an agar plate, and then the agar plate is incubated. That allows the bacteria can grow, and you can see there are all kinds of lovely and not so lovely bacteria there, and molds and things as well on a person's hands. So it can be quite shocking to do this exercise, even after somebody has washed their hands, or they think their hands are clean, and they put their hand down, and this is what can grow, 24 to 48 hours later. This is what you're seeing on a plate. So hand washing, and I think, in recent times, we've all become more aware, hopefully, of hand washing, but for anybody working in a food business, it should be second nature at this stage. There's a whole range of times when you should wash your hands regularly and thoroughly, really before switching from one activity to another, before starting food prep, after handling raw meat or poultry, touching your hair or face. And sometimes we're not even aware of these things that we're doing, but just to become aware, I've put something in the bin there, or I've brought something out, I need to wash my hands. After smoking, going to the bathroom is an obvious one, we would hope, before and after wearing gloves. Emptying bins, etc., touching your phone, touching money, touching anything that comes into contact with other people's hands and may potentially be contaminated with bacteria. Good hand washing facilities should be available in every food business. Ideally, there should really be separate sinks specifically for hands, so where there's no food preparation going on. Again, to avoid cross-contamination of any food that might be nearby, or cross-contaminating the sink. Ideally, you'd have a touchless tap. You could operate with your knees or with your elbows. Like soap dispensers should be kept clean. Paper towels rather than, fabric towels. And a bin to dispose of the paper towels, ideally with a foot pedal. So again, you don't have to handle it after you've just washed your hands. So these are the areas most frequently missed during hand washing. You can see that around the thumbs there, and around the nails, the tips of the fingers. So it's really about your technique and making sure that you're cleaning every surface of your hands thoroughly. And hand washing, you should spend at least 20 seconds at the rubbing action. So you've got your soap and water, and you need to spend at least 20 seconds cleaning your, rubbing thoroughly. So it's that action that will remove, with the soap and the water, will remove any bacteria from your hands. And then you're rinsing off and drying. And drying is very important because damp hands can spread bacteria very easily. So again, thoroughly drying is really important. Hair, you can see another picture there of a hair on an agar plate and the kind of bacteria that can be on a hair. So that's why we're hair nets. Well, nobody wants to see hair in their food anyway. But apart from that, the yuck factor, it's also potentially harboring millions of bacteria. Hair can also get into food very easily and go unnoticed. Hair nets should be obviously thrown out after one use, or if they get damaged, if there's a tear in it or anything, throw it away straight away. And then wash your hands again after changing a hair net. It's similar to changing gloves. Your hands can be contaminated after changing the hair net, so wash your hands again. Jewelry. You can see there with the rings, again, putting it down on the agar plate and then incubating the plate and seeing what bacteria will grow on it. Jewelry, watches, things like that can harbor bacteria. If you're washing your hands and you've got rings on them, then, potentially there are bacteria underneath the rings that won't be washed away. So you need to obviously be careful about jewelry, remove jewelry when you're working with food. The jewelry could potentially get into the food and go unnoticed. So then you've got a hazard there from that. Shoes, it's a good idea to keep everyday shoes that are worn outside out of a food facility. So shoes are covered in bacteria from the environment. So again, think about getting people to change their shoes or using shoe covers or things like that. Having separate shoes for inside the facility and for outside. Nail varnish, unless you're wearing gloves. And again, you need to be careful about your hand washing even when you are wearing gloves. Nail varnish mustn't be allowed. It can chip and get into food. Similarly, false nails, which I know are quite popular now, the last thing you want is them falling off and getting into the food. Could also be a source of bacteria. You know, perfume and aftershave, if you're producing food, if you're working in a processing facility, it can be can be better to avoid wearing perfume or aftershave and keeping makeup to a minimum. Again, you're trying to avoid any physical contamination of the food. Skin is a natural source of infection, and we saw the example earlier on of Staphylococcus aureus and how a lot of people naturally carry that on their skin and they wouldn't even be aware of it. So cuts and abrasions can become infected, so these must be kept covered. Again, if you're using any, if you've got any plasters or dressings, they need to be brightly covered so that you can detect them in case they do fall off into the food. And food workers must report all instances of any vomiting or diarrhea or skin infections to their supervisor, and they must not work while they have these symptoms. So it's really important, it's a legal requirement that you take that responsibility and you don't put other people at risk by, you know, working and handling food when you could potentially be a source of infection. And you must receive medical clearance before returning to work. So again, that's finished up a kind of whistle-stop tour of, you know, preventing cross-contamination and personal hygiene. Food safety is a shared responsibility. So every single person, there may be a designated food safety manager in your business, but it's everyone's responsibility to make sure that the food you produce and sell is safe. So thank you for your attention. I think we're going to leave questions till the end and we'll do a bit of a panel discussion once everybody's had time to speak. I'm going to stop sharing my screen now and I'm going to hand over to Kieran, who's going to give you some examples and case studies of, you know, food safety problems that he has encountered in various businesses.
Okay, good morning, everybody. I'm just going to talk a bit about some case studies on food safety. And the reasoning behind this presentation is to get across the message that it can happen to you. I know Linda at the beginning of her presentation showed a case from England that was ended up in a clinical situation. And I'm not going to go near clinical situations. I'm just going to give a few case studies on the occurrence of food poisoning bacteria in food premises. And if you have the food poisoning bacteria in your premises, it can very easily transfer onto food and end up in a situation like Linda showed you. But I don't want to go to the actual clinical cases, as I said. I just wanted to show that it is possible that it can happen to you, and give some examples of that I have come across in my work. But before I do that, I suppose there is the obvious public health concern that Linda talked about, which to do with food poisoning bacteria, that it can cause illness and damage to people. But it can also be a concern for industry with regards to the occurrence of bacteria in the food processing environment that can lead to recalls and withdrawals, which don't necessarily have a public health concern. They certainly can have a public health concern, but they don't necessarily have a public health concern. But they are extremely important from a point of view of industry in terms of reputational damage that can be done by being associated with food poisoning bacteria. And just remember, my first slide in all of this is that it can happen to you. It has happened to others in the industry, but it can also happen to you. So the case studies that I'm going to show you have occurred with different bacteria. Listeria, you will notice that quite focused on Listeria because I did a lot of work on Listeria. But I've also got some examples of pathogenic E. coli and Staph aureus. And then I also have a case study that I can show you a bit on in terms of the use of detergents for cleaning, and that kind of links in with the next presentation by Eddie O'Neill. So the first case study is to do with Listeria in a processing environment. And if you look at the right-hand side of your screen, the X marks on the layout diagram of a generic food processing environment show that the occurrence of Listeria. And if you do counting of the X's versus the O's, the X's are positive samples and the O's are negative samples. You find there's about 45% positive. Now, we went into this processing facility confident that we wouldn't find any Listeria because Listeria was analyzed regularly in the facility by the food business owner and none were ever found. So we were confident that we wouldn't find any. Now, don't worry too much about the different color X's, that's for a different purpose. But just look at all the X's that there were. So we did actually find a lot of positives. So we had a chat with the food business owner, and just gave some general advice, nothing rocket science about it, just cleaning and hygiene and tidying and that kind of thing, detergent use. And we went back again a month later and took the same samples, more or less from the same places. And you can see on the right hand side of your screen, a month later, after corrective actions were implemented, the occurrence of Listeria was far less. There was just 3 positives out of 50 that we took. So this just demonstrates that paying attention to detail in cleaning can have an impact on the occurrence of Listeria in the food processing environment, therefore reducing the risk of cross-contamination onto the food. I would rather have food from the right-hand premises than from the left-hand premises. There'd be far less risk of Listeria in food from the right-hand premises. The next slide, I skip to the third one. This is work that we did at different food processing environments over a 2-year period. 1 year is shown in the gray bars and the next year is shown in the blue bars. And you can see in a general sense that there is an occurrence of Listeria in many premises, food processing environments from 1 year to the next. But I want to focus on 2 of them where there was a big difference between the first year and the second year. And if we take the one around the middle, food premises number 12, the first year there was quite a low occurrence of Listeria, maybe 5%, and the second year it was up above 20%. And we discussed this with the food processing environment owner to know what was the difference between year 1 and year 2. And I'm not saying that the discussion we had with them was definitively scientific or anything like that, but a major difference between the 2 was the fact that in the second year, when the occurrence was high, there was new equipment being put in the food processing environment, and the installation of new equipment or building works or something like that is commonly known to have an impact on the occurrence of Listeria, because you've got people coming in and out from the premises to fix things or to install things, and they're not so used to the idea of hygiene. And the message here is that if you are getting new equipment installed, be diligent with the installers or the builders about the possible occurrence of Listeria, and be particularly diligent after the work has been done. It's not very fair to ask the plumber to go out and change the clothes and put on different shoes and then get a screwdriver and come back in and do the whole lot again. Not very feasible to be doing that, but certainly it's more awareness about it. And then when the plumber is finished, be particularly vigilant about cleaning up and hygiene afterwards. And if there's new building going on, have a barrier between existing food processing and the building, a physical barrier, so that there can be no or limited opportunity for cross-contamination. And also be extra vigilant about cleaning in situations like that. So the one then that you can't see the number, but it's the first one. The grey bar is nearly at 15%. So the first year there was nearly 15% of samples were positive for listeria, but the second year there was none. So again, this was an interesting difference between the 2 years. And when we discussed this with the food processing manager of the food processing facility, we discovered that in the second year they started using a caustic solution to wash up their pipes and to let that solution run onto the floor and down the drains. And this coincided with complete elimination of listeria from the food processing environment, which is an interesting thing that, if you like, it's additional hygiene measures that were being implemented in the facility, and that coincided with a massive reduction in the occurrence of listeria. So this kind of goes to show, in a sense, that management within the food processing facility can have an impact on listeria occurrence, and therefore the reducing considerably the possibility of cross-contamination. The third example, again, it's a listeria example, and it's just an example of transfer of listeria from a farm to a processing area when you've got the farm and the processing area close together. It was started out with a contaminated cheese, and in order to investigate the source of the listeria in the cheese, we did extensive swabbing of the facilities and of the farm. We took hay in the farm, cheese press, drains and floors in the processing environment. And what we found was that you had the same type of listeria in the hay as you had in the cheese press, and therefore it can get transferred from the cheese press onto the cheese. So when we discussed this with the food business owners, a complete cleanup of the operation in the processing facility, improved handling conditions, and then in follow-up work there was no further contamination on the swabs or the cheese. And what this demonstrates is that you can get transfer of bacteria from the outside to the inside of a processing facility. And I suppose you can't eliminate the possibility that the transfer was from the inside to the outside. But with the study that we did, there was no way to distinguish between those two possibilities. But we do tend to think the kind of worst case scenario is that the transfer was coming from the outside to the inside of the facility. Although 100% evidence of that wasn't obtained. But it does show that whether the transfer is from inside to the outside or from the outside to the inside, it does show that barriers between the farm facility and the processing facility are needed in terms of awareness about the transfer, close changes, footpath changes, and the proper, when I say footpath, I mean a footpath has to be something that's monitored almost daily. It's not something you put there and you leave there for a couple of weeks before looking at it. It's somebody needs to be in charge of the foot bath and to make sure that there's enough detergent in it, make sure that it doesn't dry out, and all that kind of thing. But awareness of the possibility of transfer of bacteria from outside to the inside of a processing facility is certainly a lesson worth learning. Pathogenic E. coli, Linda introduced you to pathogenic E. coli, and we did have a situation where cheese was made with milk from sheep, goats and cows, and it was all stored in the same room. And pathogenic E. coli were detected in the cheese made from the one species, but because they were all stored in the same room, all the cheeses were destroyed because of the possibility of cross-contamination from one cheese to the next. So it wasn't only the cheese from the goat milk that was taken as contaminated, it was all the cheese in the whole facility. So I suppose the lesson from that is that if you are making cheese from milk from different sources, try and keep the manufacturing and storage completely separate, and write that separateness, if you like, into documentation, so that if there is a problem with milk from one source, then you can demonstrate that the cheeses are kept separate, and that there is no risk of cross-contamination from one to the other. So in that case, it was to do with milk from different species. But then if you're making, for example, a raw milk product and a pasteurized milk product, planning to try and keep the two of them completely separate. So if there's an issue with the raw milk product, for example, then your pasteurized milk product is completely separate and won't need to be destroyed. Toxin producing Staph aureus, we did have a case of toxin producing Staph aureus in the cheese. The source could be from a human source or from a bovine source. So in order to try and determine where it came from, we did sampling of the milk and the piping system for the milk, cheese vats, all that kind of thing, and identified the source as the pipes that were bringing the milk into the cheese vat. So a cleaning of the piping system resolved that issue. Again, it goes to show that while we can talk about toxin producing Staph aureus and all of that, from a theoretical point of view, this actually demonstrates that it can happen, and it does happen. Final one is one graph that you can look at in 5 minutes, but there's about 10 years work in this graph. So it's not something that happened over a short period. This story, if you like, developed over a very long time. And initially in this food processing facility, there was a mild detergent used. The reason was valid enough, I suppose, for using a mild detergent, in that the ripening process of cheese required the presence of bacteria from the food processing environment. So if you use a mild detergent in cleaning, then you have the cleaning done and all of that, but you haven't got severe cleaning that would get rid of the bacteria that would be beneficial for the ripening process. And this is a kind of a balance, if you like, between what Linda was talking about in terms of beneficial bacteria. Some bacteria are beneficial, and this process are required, if you like, the bacteria from the environment to cause the ripening. So using a very strong detergent would inactivate those bacteria. But on the other side of that, using the mild detergent led to the occurrence of Listeria in the cheese. And I have on the vertical axis, I have given 20. That's just an arbitrary value for the demonstration purposes of the slide. That using the mild detergent, you got the occurrence of Listeria. So a strong detergent was used, and Eddie will be able to tell you a bit more about all of this in the next presentation. But it was a strong detergent that killed the bacteria in the environment, and the occurrence of Listeria decreased to 0 for a number of years. It was a chlorinated caustic detergent that was used as a strong detergent. And then after a couple of years using the strong detergent, the food processors thought, well, we have no Listeria, can't we go back and start using the mild detergent? So as soon as they started using the mild detergent again, you got the occurrence of Listeria in the cheese. And the second change to the strong detergent was very swift. And again, you got elimination of Listeria when the strong detergent was used. That's just a demonstration that the type of detergent and can have an influence on the occurrence of Listeria, but also knowing the detergent, and Eddie will talk, as I say, a bit more about that. So just to finish off, in all of these cases, the resolution didn't involve extensive expenditure on equipment or on facilities or anything like that. It was proper implementation of practices and procedures, awareness relating to food poisoning bacteria and the issues surrounding them, attention to detail in cleaning, improving the workflows, and that by that I mean that the people at the beginning of the food processing didn't have any contact with the processed food at the end, and that there was a separation, if you like. And I know it's extremely difficult in a situation where two people are trying to manage an entire facility and go from beginning to end, perfectly aware of the limitations, and maybe it's the same person that takes in the raw materials as handles the final finished product. But you can also think in terms of movement around the facility, moving in and out of the facility, and that kind of thing. It can be a help to actually sit down at night, and when you're half watching television and half not, draw a quick sketch of the facility and a sketch of where the people go during the day, and try and limit their movement in and out of the facility, the movement around the facility, and that kind of thing, because that can help with the transfer of bacteria from one place to the next. And then detergent selection and what the detergent is intended for and can do is important. The key message is that it's within the ability of management to control a lot of these issues. And I'll link back to the very first slide and say that always remember when you're doing that, that it can happen to you. It doesn't always happen to the guy down the road. It can happen to you. And it's within your ability to manage that. And I think that part of the reasoning for jailing the people that Linda talked about was that they didn't fulfill their, or they didn't try to fulfill their duties. But I think that if you demonstrate that you try to fulfill your duties in terms of cleaning and hygiene and management of food poisoning bacteria, that will help in any serious situation, as well as, of course, that all this can help with the resolution of the issues in food processing facility, and prevent the risk of, or certainly reduce the risk of cross-contamination of food poisoning bacteria onto the food. So that's all I have to say at the moment. Thank you very much for your attention. And if anybody has any questions, my email address is there, and you are welcome to drop me an email with any questions. So we'll have a question and answer session at the end. So at the moment, I will introduce Eddie O'Neill. Eddie is, as I say, artisan food development person with Teagasc, but he's also certainly my go-to person in terms of detergents and cleaning regimes. So Eddie, over to you.
Thanks very much, Kieran. Can you unshare there, Kieran? And I'll thank you very much. If you just bear with me for a moment, and I'll pop up my presentation. Here we are. Please start working. Lovely, lovely. Great. Good morning, all. Thank you very much, Kieran. Cleaning and hygiene. Food manufacturers are obliged to, sorry, just I minimize that. Food manufacturers are obliged to maintain high hygiene standards. It not only applies to the plant and equipment, but also to the staff in the actual production areas. Visual appearance is very, very important. So that slide is absolutely beautiful. Floors are spotless, the equipment is spotless, and first impressions are very, very important. Generally speaking, if a place looks clean, it generally speaking is clean. But why do we need cleaning? Food residues provide an environment where microorganisms can grow, and they must be eliminated. We need cleaning to reduce the risk of food spoilage and food poisoning, to allow for disinfection of equipment and work surfaces, to reduce the risk of contamination by foreign matter, and to promote a hygienic and well-run image to our customers. Good wholesome products that keep well and are free from hazards are good for a trade, and your customer will buy again and again. But the reverse is also true. If a product is contaminated, the publicity can be very, very damaging for your company. The potential effects of poor cleaning and poor standards must be kept in mind at all times. And then there's the trust issue. Customers will never see the factory or see how the product is handled or produced. They take a company on its reputation, and they trust that that company is doing everything to produce good quality food. And they take it for granted that the food is produced under the cleanest of conditions by very well-trained staff. On the legal side, the law is there to protect the consumer in respect of food safety, hygiene, and so forth. Failure to meet these obligations by the FBO, the food business operator, can be very expensive. Always remember that prevention is better than cure. What we found in our experience is that instructing people is never enough. In order to maintain high standards, they must understand the reasons why cleaning is important. It's often seen as a necessary evil because it costs money. And yes, it does. There's the cost of labor, the cost of treating your water, heating, the cleaning equipment, chemicals, effluent, and of course there's downtime. It takes a number of hours to clean a factory from top to bottom. But all of these costs should be part of your daily production process. Apart from the cost, there are additional reasons. Reduces the risk of food safety hazards, including cross-contamination, foreign body contamination. To meet specific customer requirements, maintain product and help to extend product shelf life, ensure safe working conditions for staff, which is also critical. And there are three basic types of cleaning. There's the actual physical cleaning, which is the removal of all visible dirt. Chemical cleaning, which is the removal of microscopic residues. and bacteriological cleaning, where we're killing off bacteria, and that's attained by disinfection. Now, the nature of soiling is basically organic, inorganic, and biofilms. On the organic side, we have fat, protein, cooked or hard deposits, and they very much build up, especially on hot surfaces. And these are very, very difficult to remove. If you can imagine your car during summertime and you're driving around the country, you get lots of flies and moths and other insects on your car, and they're very, very difficult to remove. Very difficult. And why are they difficult? They're difficult because they contain protein and fat. And protein especially is hard and sticky. And when it dries onto your car, it's incredibly difficult to actually remove it. And what you have to do, you have to bring it to a car wash, and then you take out your hose and you pre-rinse it, which is what you would do in a food environment in a factory. And then you use a detergent and scrubbing brush, and then that's rinsed off with more water. So if you can imagine what you have to do to get rid of all those deposits on your car, it's the very same scenario in a factory environment, whether you're working in a deli or working in a large factory. On the inorganic side, we have phosphates, carbonates, calcium deposits, and biofilms then we'll talk about a little later on. Fats and oils and so forth, they vary from waxy solids I'll just move that fella down there a small bit. They vary from waxy solids to liquids, usually insoluble in water. So examples of food high in fat are on the top right-hand side: butter, cheese, nuts and seeds, fatty meats, chocolate. On exposure to air, they oxidize, and they can become hard and more closely bonded units on surface. That's why we always recommend clean as you go. If you allow fatty products to harden, they're incredibly difficult to remove. Exposure to high temperatures can cause fats to burn on or carbonize, and they're recognizable by their greasy feel and water repellent properties. Proteins, wonderful in one way and an absolute nuisance in another. They're large molecules, too large to dissolve in water, generally speaking. The specific shape changes when exposed to high temperatures, and it denatures. And this makes them harder and more insoluble, more difficult to remove in a food factory environment. Again, it's very, very important to have correct temperature and correct detergent to remove these proteins. Again, if they're allowed to dry on or harden, they can be incredibly difficult to remove. We should always remember as well that almost all allergens are protein in nature. And I just want to mention this, even though it's the area of one of our colleagues in Safe Food, James McIntosh, who's an expert on allergens, and Jane sent me on this slide. They're mostly protein and they're normal constituents of food. Allergens are not another form of food poisoning caused by contaminants that shouldn't be in food. Allergens cannot be eliminated by baking or cooking. And intolerance reactions can also be triggered by other food constituents, such as lactose, histamines, and so forth. And allergens should be controlled based on HACCP principles. But I just wanted to mention because they are usually protein-based products, and proteins are very, very difficult to clean. A lot of food ingredients contain starches, could be modified starches, could be plant starches, and they're usually derived from plants. They're very, very large sugar-type products, and they tend to burn on, especially with heat. They can be soft powdery to quite hard, but again can be very, very difficult to remove. Yeast and molds are probably the most common contaminants, and they result in food spoilage, not necessarily food safety, but food spoilage. Yeast is found in moist areas, especially where high levels of sugars are present. Mold found in moist areas, especially near chills, freezers, and you'll often see little black dots on silicone sealants. Don't even try to wash it out. Replace the sealant, remove it, and replace it with new sealants and so forth. Again, mostly associated with contaminants, especially in cheese, yogurts, and so forth. They look unsightly. When we look at cleaning agents, then we have detergents. And detergents are used to remove fat, protein, starches, and so forth. And when we have organic soiling or organic debris, it takes the form of fat and grease, and we use an alkaline detergent. I'm not going to go into specific names from specific companies. If you want individual advice on that, you're welcome to send me an email at a later date. Proteins, though, are very, very difficult to remove, and usually we use a chlorine-based alkaline detergent, and that chlorine has a greater hit on the protein. Starch, then, an alkaline detergent again. And alkaline detergents, their pH varies from 8 to 14, so they have a high pH. And they're a combination of chemicals, including surfactants and chlorine. But blends are also much more effective, but they are more expensive. A lot of them contain surfactants, and these are surface active agents. They contain hydrophilic, which is water-loving end, and hydrophobic, which is a water-hating end. They improve the wetting power by reducing the tension in the water surface. They allow water to get in and penetrate the soil and gives a greater cleaning action. But it also keeps the soil in suspension in the water, and it prevents redepositing further down the plant. On the inorganic soil, which are mostly minerals, as I've said already, calcium, phosphorus, limescale, we use acids. And these acids usually contain chelating agents. Acid detergents, pH from 0 to 6, they may have chelating agents added. They're very, very effective at removing scale, but they should not be allowed to come into contact with chlorinated detergents. Also remember that while they're very, very good at removing scale, they're also one of the few methods of killing thermoduric bacteria. And thermoduric bacteria survive pasteurization, but they're very, very susceptible to acid cleaning. Chelating agents, from the Greek meaning claw, it grabs onto metal ions. It removes inorganic elements, and it prevents hard-scale deposits. And it's usually added to acid detergents in very, very small quantities. Again, the blended detergents are much better than the individual units. Some bacteria produce polysaccharides, which are sugars, basically. And I just moved this, sorry, I'll move this if I can. Sorry, just for a moment. Some microorganisms produce polysaccharides, which are sugars, long-chain sugars. And these have the potential to combine with salts to create biofilms. They are tenacious and very, very difficult to remove. But what happens over time is that the bacteria then, sometimes harmful bacteria, grow inside these biofilms, and then they break open, and they give intermittent positive and negative problems inside in your food factory. A sanitizer then usually refers to a product containing a detergent and a disinfectant, such as a chlorinated detergent. A disinfectant is a product which kills microbes with the use of a soil remover. Quats, quaternary ammonium compounds, peracetic acids are disinfectant. Sanitizers are usually added to a detergent such as chlorine. When we look at disinfectants then, halogens, chlorine and iodine are commonly used. Iodine was often in the past used in baths to store removable pieces of equipment. Nowadays, we tend to use peracetic acid, and they are called ORCs, or oxygen releasing compounds. Peracetic acid is the best disinfectant you can possibly get. It has a great kill effect on listeria and all other bacteria as well. However, the most common disinfectant used in industry is quats, or quaternary ammonium compounds, and amphoteric compounds. And while they're very, very good at what they do, they're often used for fogging and so forth. They don't have a huge effect on yeast and mold, so it depends on what you're actually trying to kill. And when it comes to washing factors, we always use TACT, which is time, action, concentration of detergent, and the actual temperature at which you're washing. Not enough time, you don't get enough surface interaction. Too much time, the temperature can cool, the detergent will deposit and leave streaks on your equipment. Get it right, the surface wet, soil is removed and washed away. Always follow manufacturer's instructions. Action is about mechanical force. It could be foaming, it could be manual cleaning, it loosens soils and disrupts biofilms. Chemical concentration is very, very important to follow the manufacturer's instructions. Not enough, it won't do the job. Too much, you'll end up with residues. So try to get it bang on, get it right. Use your correct temperatures according to your operating practices. And again, observe recommendations from your cleaning supplier. Water should always be at a minimum of 50 degrees centigrade. But too hot, in terms of greater than 65, proteins may denature, but you also might damage seals in your pipework. So the little black seals called benzyl butyl rubbers, they degrade at temperatures higher than 65 degrees. So you have to be careful as well. Basic cleaning steps would be a pre-rinse to remove loose soil prior to cleaning. Use warm water at 50 degrees. Wash using tact. Post-rinse, rinse water may be acidified, and then sanitize by circulating or spraying down with a disinfectant such as peracetic acid. There's various cleaning steps. There's foam cleaning, which is commonly used in industry, and the bubble has a mechanical effect. We have manual cleaning, which is about getting a bit of elbow grease out there. And of course, fogging. And fogging can be used once a week, once a month. Generally speaking, if you have a problem, especially with yeast and molds, we would increase the frequency of fogging to eliminate the problem. And then you can reduce it accordingly over time to come up with what is the best scenario for your own factory situation. CIP, or cleaning in place, is about the large factories where the interior cleaning of the pipes, and you have a programmed cycle, you have a turbulent flow of about 1.5 to 2 meters per second, and it's all controlled, and the detergent is controlled, and the time, temperature, and all that is controlled, and that's cleaning in place, or CIP. Whatever you do, you must have a validation procedure. You must document the actual cleaning procedure. You should have a clear cleaning schedule, and you should have monitor checks. And a very simple look around the plant visual. What we tend to use is ATP, and every organic compound contains ATP, adenosine triphosphate. And what we do is a simple swab on our wash water into a machine. We have the result back in less than a minute. And that tells us if our detergent and our cleaning system has been doing a good job. If the levels of ATP are high, then we are not cleaning properly, and we go back to do it. And again, train your employees, but retain complete records at all times. It's very, very important for inspections. Your equipment should be coded. Blues for vessels, for tanks and so forth. No crossover from blue to red, from high risk to low risk areas and so forth. And again, cleaning, and now we're in the middle of COVID. In some factories, because we're short-staffed and so forth, our quality staff being removed to cover the COVID rules and regulations. Because visitors to the plant, workers in the plant, you take the temperature daily, you write down the time and so forth. But don't forget what has served us well in the past, and that is a clean regime. And if you continue to have a clean regime and process, you won't have problems. Some key points then before we finish. Clean surfaces are necessary to ensure satisfactory disinfection. So they must be cleaned with a detergent first. Facilities and equipment must be adequate to do the job effectively. The efficacy of disinfectants depends on the chemical composition, the time, and the temperature. And each disinfectant has its own unique properties. Protocols must always be in place. Chemicals must be used and stored away safely. Use combined detergent sanitizers rather than separate chemicals. It saves time and money. Keep the number of chemicals in your premises to a minimum and never mix them. They might become neutralized or indeed become toxic. And again, there's a number of links on the Safe Food Net, a number of videos on cleaning of equipment, on hand washing, and these are very, very useful tools for staff. And on our own website, moorpark.ie, where Safe Food is partnered with Moorpark Technology Limited, there's educational videos for effective cleaning of equipment, personnel, and personal hygiene. Thank you very much. Sorry, I just stopped sharing. No.
Thank you very much, Eddie. And thanks to Kieran and Linda as well for taking time off their busy schedules today to join us and give us very interesting and informative presentations. I suppose I'd just like to let everyone know that the presentations will all be available for future reference on our Safe Food Knowledge Network website shortly. You can sign up for free to access these at safefoodkn.net. I suppose I will kick off our question and answer session. We've had a lot of questions coming in throughout the session, so I will not direct them to anyone. Whoever's most qualified to answer can pick it up. So we have a question on what is the legal position on the sale and consumption of raw milk in Ireland?
I slightly answer that in terms of it's the responsibility of the food business operator or the farmer, whoever is selling their raw milk, to be registered with the Department of Agriculture before the sale of raw milk takes place. I also have a document that I produced myself on the production of liquid milk, and if Jane wants to send me an email or anybody else at eddie.o'neill@teagasc.ie, I can forward on that document as well, and all the details are contained within, if that's okay.
Perfect. Thank you, Eddie.
Can I add?
You can add.
Can I add to that? And I wouldn't disagree with any of it, but people should also be aware that there is an agreement between raw milk producers in Ireland and the Department of Agriculture. There's a document on that. It's not legally binding. It's guidance, I suppose.
Guidance, yeah.
For raw milk producers, in terms of hygiene and cleaning and quality and all that. It's certainly worth having a look at, because it's an agreed document between the department, who are the regulators, and Raw Milk Ireland, who are a group of raw milk producers. And it certainly is very good in terms of addressing the issues of concern.
Okay, and I suppose just to note that that advice is for people in the Republic of Ireland. So I suppose the Food Standards Agency or the Department of Ag in Northern Ireland probably have separate documents for anyone in Northern Ireland. So another question, is it acceptable?
Sorry. You can find that very easily on the internet, but if anybody wants a copy of the document, drop me an email and I can send you a copy of the agreement between the department and the raw milk producers.
Perfect. Thank you, Kieran. Okay, then the next question, is it acceptable for food premises to serve beef burgers cooked to medium and obviously not fully cooked?
No. There's a minimum cooking temperature there is for burgers. I think it's, correct me if I'm wrong, but it could be something like 72 degrees for 2 minutes at the center. And that's proper cooking. And there is only one way to cook burgers that's properly.
I was in a restaurant.
Yeah, I think there's some kind of caveat that if you do want to deviate from the temperature requirements laid out, you have to have consulted a microbiologist and done all the validation work to show that whatever you're proposing is equivalent to cooking, and that's not feasible for most businesses. So effectively, no. And I think, Safe Food a few years ago, along with the FSAI and the Environmental Health Service, ran a campaign around this, where Safe Food, we were communicating with the consumers, advising them to always ask for their burgers to be well done when they're out in a restaurant regardless of what they're offered. And then the FSAI and the Environmental Health Service were, you know, giving the advice to restaurants and advising them that they should never, they should not serve undercooked burgers, that burgers should always be cooked the whole way through. But you will still see sometimes, you know, cooked to preference given as an option, but that shouldn't be the case. And we've seen that when we mentioned about the VTech E. coli, you know, it is found naturally in cattle and it will make its way into minced meat. So that's why they should always be cooked the whole way through.
Perfect. Thank you, Linda. We have another question in relation to the production of sprouts. So it's how can we reduce Salmonella, E. coli and other bacteria in raw sprouts?
I don't think you can reduce them. What you can do is you can reduce the possibility of them getting into it by having good hygiene in the premises and processing area and the fields and all the associated activities. But once they're there, I don't think you could do very much to get rid of them except don't have raw sprouts anymore.
Okay, that's fairly straightforward.
But it's a proactive approach to reduction in the occurrence rather than a prevention approach of dealing with them when they're there.
Okay, we have another question then in relation to cheese production. Can pathogens such as Salmonella be inactivated in raw milk cheeses during ripening/maturation process? Is it possible to rely on this process to ensure the safety of the final product if Salmonella is found in the cheese early in the production process?
Kieran?
I don't think that you can rely on the process to reduce Salmonella. Again, I think the approach, and it's the approach that we would be advocating all the time, is proactive reduction of the risk of contamination. But I think that if Salmonella are found in there, no matter where in the process, whether it's early in ripening or late in ripening, I'd say you're done, basically. Sorry,
it also depends a little,
but the possibility exists that the ripening process will reduce pathogenic bacteria, but the reduction would be different for different bacteria. In fact, not all Salmonella would reduce at the same rate. So the prediction of the reduction and the rate of reduction would be a bit all over the place. So I wouldn't rely on anything like that at all. I think prevention of it getting in there is the key aspect.
Perfect. Thank you, Kieran. The next question is in relation to cleaning. So the question is, do you need to rinse off disinfectant? And also another part of the question is, would you suggest a specific detergent?
I prefer to get an email on a specific detergent.
Okay.
You know, you can actually Google. I do a lot of work with a company called BioCell. They're very, very good, and they have a great range of detergents. So does Water Technology. They have a great range of detergents. Generally speaking, you would rinse off your disinfectant prior to production. But with some of the disinfectants, there's no need. So the likes of peracetic acid, it's a very, very low level and it breaks down naturally over time. Some people do rinse it, other people don't. But generally speaking, I would recommend you disinfect and then you rinse prior to production again.
Perfect, thank you. Eddie, there's another question on cleaning in regards to contact time for cleaning agents. So I suppose the question is, you know, if it says to leave a detergent or a clean agent on for 5 minutes, contact
for 5
time,
minutes, or you know, if you're using foaming, you know, the contact time is usually in the range of 5 to 15 minutes. If you're using CIP inside and pipework, it's usually 20-25 minutes at the cold end. Again, follow manufacturer's instructions. The specification sheets are very, very clear, depending on what you're using.
Okay, thank you. If it's still necessary to use PAL if you clean your equipment / facility with a chlorine-based alkaline detergent? Eddie, you might understand that because
Right. If you use a chlorine-based alkaline detergent, chlorine is becoming a no-no in the industry because of the risk of chlorine contamination, but usually only if you're exporting food products, right? Chlorine-based detergents are incredibly strong, right? And you get away without using a terminal disinfectant when you're using a chlorine-based sanitizer. However, as I said in one of my slides, I would generally speak only use a chlorine-based detergent if I have difficult protein to remove, right? I would then rinse it out, but I would still, just me personally, I would still use something like peracetic acid as a terminal disinfectant. Some people don't do it. I just think you get a wonderful kill and you get really, really clean work surfaces.
Okay, thank you, Eddie. We have another question. If a food business operator tries to do their best in terms of hygiene in their food premises, and yet there is an outbreak of foodborne illness on their premises, obviously, what happens to the FBO in terms of their legal responsibility?
Who wants to take that?
I suppose it depends. Like, people would be prosecuted if they found to breach certain regulations. So if there's an outbreak of food poisoning, then, you know, it's unlikely an outbreak of food poisoning will happen if people have done everything possible. Sometimes maybe the fault may lie with the supplier or something like that. It depends on what circumstances and what breakdown of food safety led to it. I think it goes to the legal, I suppose, concept of due diligence. If you've done everything you could possibly or reasonably be expected to do, are you protected? I hate to go from one thing to another, but I do think we have a webinar on due diligence. That's that a lawyer did for us. I'm not a legal expert, and none of us here are regulators, so it's difficult to give you a definitive answer. You know, most of the time when you see cases of food poisoning, there have been very clear breaches of food safety legislation and food hygiene legislation. Yeah, I suppose you could have a scenario, like I said, where there was a supplier at fault and that there was nothing that, you know, somebody owning a restaurant or whatever could have done. However, so, you know, again, there'll be an investigation and trace back, and that is where I would advise keeping all your records, you know, in case there is an investigation. Sometimes if you run a restaurant, maybe one of your suppliers, there's a problem, but if you have your traceability records, if you have everything in place yourself, that gives you, you know, the better chance of sort of defending yourself if there is any investigation going on. But you know, again, I would suggest maybe if you want to have a look, it is quite a long webinar as far as I know, but there is one on our website, safefood.kn.net, that goes through that in more detail if you are interested in that sort of due diligence defense.
Can I just add to that? I'm not going to say anything different, but I'm always reminded of the cantaloupe outbreak. There was racial hysteria back in 2011, and the Jensen brothers, and I know some of you will be familiar with that. Jensen brothers were jailed as a result of that outbreak. The principal reason I understand that they were jailed was because they had a cantaloupe washer on their premises that they didn't use. So they didn't show due diligence, and so therefore they were jailed. So I think that due diligence won't stop you. This is a personal opinion. Due diligence won't stop you from being prosecuted, but if you have and can demonstrate from your documentation, as Linda says, you can demonstrate due diligence and making every effort to reduce the possibility of contamination, then you have a much better defense.
Okay, thank you, Kieran. We've lost Eddie. He must have got cut off. I've a few more questions. I don't know, are you okay in terms of time?
Yeah, I'm fine.
Yeah. Okay. What is the main contaminants and bacteria one would watch for in the production of bread or confectionery? Yeah.
Good one. I think that you can't get away from the main pathogens, and I don't think that bread or confectionery would necessarily be very different in terms of, for example, listeria or that you can get cross-contamination, and even though they might not survive on the bread for very long, it all depends on different things. But spore-forming bacteria, because they survive cooking, for example, would be something that should be considered. I'm not saying that you have to do tests all the time for them or anything like that, but it just would be, because the spores can survive the cooking process, then that is a consideration. But again, I come back to the issue of cross-contamination, because although something might be killed by cooking, if you don't have a clean processing environment or a finishing environment afterwards, and you don't have proper handling of bread and all that after the cooking process, then you do run the risk of cross-contamination. So awareness and care and attention to detail in handling the after cooking would reduce the possibility of the kind of foodborne bacteria that we're talking about, because they would still be relevant in terms of bread as much as in terms of dairy products or meat products or anything like that.
Perfect. Thank you.
Again, if anybody wants further information on that, drop me an email and I can investigate it a bit further, because I must say that bread and confectionery wouldn't necessarily be my area of expertise, but I can certainly make some inquiries further if anybody wants further information on that.
Okay, thanks, Kieran. We just have one question about shoe covers. Someone's asked about trading in food markets and like food gazebos. And I suppose it was what Linda mentioned, shoe covers, and they're asking, you know, where
I mentioned, I think, advice about, you know, having different pairs of shoes for inside or outside. You know, that would be more applicable maybe to a fruit production facility. You would see that kind of thing. Shoe covers, you know, they're an easier solution to it, but, you know, obviously all of that is not relevant to every single possible food premises, but it's just, I highlighted, so if you're working in an outdoor facility, then obviously it's a different situation, and it's not going to be so easy to do that. But it's just about awareness of where contamination can come from and trying to reduce that. So, you know, it might not be possible in your premises to, you know, might not be practical to use food covers if you're, you know, outside or outdoors, or to have changes of shoes and things like that. But just to be aware of where contamination comes from. And I suppose what we're trying to get across, all of us, is about cutting down the risk or reducing the risk at every possible stage, you know, to reduce ultimately the overall risk of contamination of your products. So you look at every possible stage where contamination can be introduced.
Okay, thank you, Linda. We have two remaining questions, but they're both in relation to fogging. So I could get Eddie to answer them and add them on a Word document underneath the videos, if that's okay.
I can add a brief comment on that, I suppose.
Okay, someone's just asking, Kieran, what the pros and cons of fogging are.
Fogging is a good cleaning method. If the right products are used in the fogging, you can get into crevices, nooks and crannies that cleaning won't get into. The pros, that's pros, if you like, that you do get into areas that would be more difficult to get in terms of cleaning. Peracetic acid you can use for fogging. Just need to be careful that you don't use the wrong products and get contamination in terms of taints and residues and that kind of thing. But again, if fogging is done with a proper awareness of the right time to do it, and the right products, it is a very good method of cleaning, but shouldn't be used. I suppose it shouldn't. It's not a method of cleaning. Sorry, it's a method of disinfection and hygiene. You can't use it as a cleaning, because you still have to get in there and clean, and it's something that should be done after cleaning. I think I might have made a mistake in my first comment. I was thinking in terms of, is fogging a good method to use, full stop. No, it's not a good cleaning method. It's a good method to use after cleaning. Eddie might be able to give a bit more of examples of what products to use and that kind of thing. But cleaning, as with all disinfection and hygiene, cleaning has to be done first.
Okay, thank you, Kieran. Well, I think we've answered all the questions. I'd like to thank the speakers again. Thank you very much. And just remind everyone that the presentations will be available on our Safe Food Knowledge Network shortly, when we can get them up there. And thanks very much for everyone attending, and thank you.
Thank you. Take care.
Bye-bye.